This question tells us for butanoic acid, the Ka equals 1.51 times 10 to the minus 5 moles per decimeters cubed. It tells us how much sodium hydroxide and butanoic acid are added to a solution, and it wants us to calculate the pH of the solution formed. Let's start off by finding the moles of sodium hydroxide and butanoic acid. So the moles of sodium hydroxide is concentration, which is 0.1, times the volume, which is 0.02, because we divide the centimeters cubed by 1000 to get 0.02 decimeters cubed, and that is 2 times 10 to the minus 3 moles. The moles of butanoic acid, I'm going to write that as HX because that is our acid. That is going to be 0.1 times by 0.025, which equals 2.5 times 10 to the minus 3 moles. So the sodium hydroxide and the butanoic acid will react with each other to form the sodium butanoate salt. So let's subtract each of the moles to find how much of the acid is remaining. That's going to be 2.5 times 10 to the minus 3 minus 2 times 10 to the minus 3, which equals 5 times 10 to the minus 4. That is the acid, butanoic acid, remaining. And then, of course, we will have 2 times 10 to the minus 3 moles of X minus, which is our salt formed from this neutralization reaction. So we need to find the pH of the solution. Let's write the equation out. So Ka equals H plus the concentration of hydrogen ions multiply the concentration of salt over H, the concentration of the acid. Let's rearrange that to make the proton concentration the subject. It's going to be H plus in square brackets equals Ka multiplied by Hx over the concentration of X minus. So we have the moles of X minus and Hx, but we don't actually have their concentrations. We know that concentration equals moles over volume, and the total volume we have now is going to be 20 centimeters cubed plus 25 centimeters cubed, which is 45 centimeters cubed, which is 0.05 decimeters cubed. So the concentration of Hx after the two solutions are added to each other is 5 times 10 to the minus 4 over 0.045, which equals 0.0111, and our moles of X minus are 2 times 10 to the minus 3 over 0.045, which is 0.0444, both in moles per decimeters cubed. So let's substitute this and this into our equation for the concentration of hydrogen ions so that we can find the pH. When we do that, we get H plus equals 1.51 times 10 to the minus 5, which is the Ka, times 0.0111 divided by 0.0444. This equals 3.775 times 10 to the minus 6. Remember the equation, pH equals minus log base 10 of the concentration of hydrogen ions within the solution. Therefore, our pH equals minus log base 10, 3.775 times 10 to the minus 6, and that equals 5.42. I'm going to zoom out so you can see all of the working out. Take a screenshot if you want to look through it. Thank you for watching the video. I hope you found it useful. If there's anything that you didn't understand or if you have any questions, feel free to let me know down in the comments below.